The overall goal of this procedure is to synthesize a high C-axis zinc oxide thin film by plasma-enhanced chemical vapor deposition, and use the as-synthesized film combined with a platinum interdigitated electrode as a sensing layer for an ultraviolet photodetector device. This is accomplished by first using a plasma-enhanced chemical vapor deposition system to synthesize the high C-axis zinc oxide thin film onto a silicon 100 substrate under the optimum synthesis parameters. The second step is to manufacture the interdigitated pattern onto the zinc oxide thin film surface by conventional optical lithography in a clean room. Next, radiofrequency magnetron sputtering is used to deposit a thin conductive platinum layer on the top of the zinc oxide thin film, and then the sample is immersed in acetone in an ultrasonic cleaner to remove the photoresist. The final step is to perform a rapid thermal annealing process for obtaining an ohmic contact interface between the platinum electrode and the zinc oxide thin film. Ultimately, the real-time photocurrent response measurement is used to show a fast responsivity and high reliability under the UV light.
The main advantage of this technique over existing methods like conventional chemical vapor deposition is that lower synthesis temperature, high aspect ratio condition is available, good surface uniformity, high deposition rate, and the chemical composition of nanoscale structures can be finely controlled.
This present plasma-enhanced chemical vapor deposition technique provides a method for preparing the zinc oxide thin film onto silicon substrates and can also be applied to the formation of other functional materials onto more flexible substrates such as graphene and other tools.